You mean to tell me that this entire time I was streaming on the wrong channel? This entire time I was streaming on the wrong channel. Oh, jeez. I messed up my stream keys. That happens. It's fine. It's okay. I. Alright, let me start from the beginning. Hello everyone, welcome into yet another live stream. Hi the generic person. Where has bro been? I'm so sorry for not streaming the past couple of days. I was feeling like shit. I had a terrible weekend. And I just unfortunately couldn't stream for that reason. I was truly feeling awful. But I'm better now, which is why I'm back. And I'm going to be twice as productive to make up for it. That's what I started the stream with. Now going back to the thing, I just did a bit of I had like a whole box of components and we just went through all of them. It is mainly an I2C hub, DAC. We also had some multiplexes. Oh, that's a button. Multiplexes, heat sinks, a knife, a ridiculously sharp knife, as we turned out, because I already used it to open the package. It was really convenient, and those snips. Because, well, I did them all as a single package. Anyway, let me restart from the beginning then. Hi there, Holy Thinkable. How is your day going? As I was saying, we will use this right here, which is an I2C hub. It is effectively 4 wires running the length of the connection. Well, that's how you can think of it. If you made a circuit, like diagram of it, it would be just 4 connections running parallel to each other. Because that's effectively all you need for an I2C hub. For I2C, all you do is you just connect devices together, which is convenient because we want to connect this right here, RFID. I watched like 100 live streams and I've never seen your hands in them. Really? I've been doing it for a while, on this desk as well. Quite a lot almost every single live stream on this channel involves my hands. It's a big part of it. What we'll need to do today is we'll need to completely rewire this RFID controller. No, not RFID controller, the RFID circuit. Because I have it set up for SPI, we needed to use it for I2C, and I do realize how I sound, okay? I do realize how I sound. We need to redo the RFID controller from SPI to I2C. I do realize that I sound mental. But it's simple, I promise. Let me actually draw it out for you, what exactly it is I'm trying to achieve. How about that? My paint doesn't always work, so for some reason, we need to be aware of that. But basically, we have our RFID, which stands for Radio Frequency Identification, in case any of you haven't seen my video, the second most recent video on it. That's the big chip with the antenna at the bottom, like this. And right now, it is connected to our Raspberry Pi, often abbreviated as RP5. It is connected via something called SPI. Now what SPI is just a serial peripheral interface. So you can think of it like USB, kind of, or you can think of it like HDMI. Just like these cables have different standards, the same way it works without the cables and just with serial connections, which is SPI. The nice thing, it's been alright, just boring. I've been able to prepare for additional time. Yesterday with a team, that was fun. Coke Sable, oh, that is really fun. I don't call it boring, that's like 3 times more interesting than what I'm doing. Now, why does Pi need an ID? It's not about an ID, this is RFID, which means this is for reading RFID cards, or reading RFID tags, or anything RFID related. Now, SPI is really fast. However, it's also really annoying to set up in parallel. That's what I've been trying to do with circuits like these. Well, this is the small one. The bigger one... where did I put the bigger one? The bigger one I was making with multiple connections. There it is. I've been trying to make a circuit like this. You can't really see it all that well, but that's kind of my point. It is really complicated. There is a lot. There is an awful lot. The reason why it didn't work is because this chip right here, it kept burning. It's really difficult to solder it, and as such, every single time I tried, this bit shift register kept burning up. So that's why I have another idea. We're gonna reserve our SPI connection for the monitor, because the monitor needs a really fast connection. We're gonna go this way. This was our monitor with the taxi on it. Beautiful rendering. And then what we'll do is we will use I2C, which is slightly slower but also easier to use, for things that don't need speed. So things like RFID, things like... well, I don't know what else will come, but some things I imagine will come. You got money for all this, but not the time to organize it. What do you mean money for all this, but not the time to organize it? Could you elaborate? What do you mean by this? What are you referring to? There we go. So what we'll need to do today is we'll need to switch up the current connection, which is this one, SPI connection from the RC522, if I'm not mistaken, what's its name? I still remember it is RC522, to this stuff on the table. Where's my work table? I keep it like that because I like having things on hand. It's much easier that way. Do you like gambling? Well, I'm about to... I've just hinged my entire project on connecting this module to this using I2C without testing it prior. So, yeah, I would say, yeah. We're about to gamble. Okay. What should we do first? Should we first design the connector and wait for it to print and then try the I2C connection? Or should we... You know, I like that idea actually. Yeah, I think first we should just design the connector and with it printing in the background we can work on the I2C connection from the RC522. This company is 100%. Brilliant. My SolidWorks will be yelling at me. I know you can't see it because it's starting, but yeah. It's already yelling at me that it doesn't have enough resources. Oh, what do you mean? You mean to tell me I cannot stream and do all the other stuff in the background without you crashing? Coward! Do better. Oh, what is your problem? Why do you always have problems? This is your problem. Why is this your problem? How could this be your problem? This doesn't make any sense. Oh, no, it does make sense because we've changed it. Yeah, now it won't be a problem. Okay, beautiful. So this right here is what Fixit looks like so far. Oh, sorry, it's upside down. There we go. This right here is what Fixit looks like so far. We don't have the top installed yet, or this Raspberry Pi Pico holder, because we don't need it. But oh, this is where the thing should go. Oh yeah, that's perfect actually. That is actually perfect. That's actually exactly where we want it to go, because right here is where we want the hub. So right now all we need to do is we need to figure out basically where to place the hub. That's where to place the hub, and then we need to make a connector for the hub that will house the hub, and the hub will hopefully just stay there, stick there, and everything will work out just fine and well, and there will be no problems. I'm certain of it. I'm certain that there will be no problems whatsoever. So first things first, let us model the connectors. Where do you want to go? You want to go, this is the back, which means this right here. So we want the I2C hub to go somewhere right in this area. The organization I'm part of is thinking of getting a CNC machine for PCB fabrication. Oh, that's neat. Considering the things you do, I'm kind of surprised they don't have a CNC already. Because CNC for stuff like these feels pretty basic. Okay, these will be our connectors. Then from them we need to, well, ideally basically like design the whole segment here. We would like to put some more things over there. The problem being that we don't know what we're gonna put over there quite yet. We could go crazy with the future proofing and design something like a, I don't know, a duck holder, for example. But I don't think there's a point. I think we might as well go with it simple and just, yeah, not overdo it quite yet. So, first things first, the measurements. Oh, my favorite, the measurements. I need to measure the I2C. This is content. This is interesting stuff. This is truly interesting stuff. So, the holes are, in fact, 2 centimeters away. So that's a 20, which means they will be a 20 away, but then we want to rotate it as well. Okay, so let's start with it at an angle already, for the sake of convenience. Then let's set it to be a 20, because that's how far away they will be. It's a fairly new organization I invested, like it officially started this semester and so far I don't know. Oh, that's what I thought you were talking about the whole, okay, that makes a lot more sense. I'm sorry, I misunderstood. Any holes goes, should we go to watch this stream? Damn it. You know what, I think I first should start the rectangle now I'm thinking about this. It should be 20 by 40. Oh, how convenient of a shape that is. So 20 by 40 is the whole shape. By 40. 40 normal units. Beautiful. So then, whoops, we're back. So then, really holy. Oh, shadow with the pants. I mean, it's funny. It's gonna get me with them, but all right. Now this is the shape itself. We don't care about the shape itself. No, we do care about the shape. Wait, do we care about the shape itself? I don't think we do care about the shape itself, which means we're gonna... Oh, it's running so slowly. I always forget just how slowly SolidWorks run when I have everything open in the background. I mean, I'm not making it easy for it, but, you know, still. Top holes are a centimeter away. Oh, how I love when just people who design this sort of thing do this, where they just put all the mounting holes and all the significant parts like a reasonable number from the edge. Stuff like a centimeter is just really lovely. Okay. This and this both need to be for construction, both need to be equal. And then they need to be... Oh, piss off, I won't be able to select... Well, I mean, I can still do this. Say, what's this project trying to do? It's complicated. It's really, really complicated. It's basically... It's a boilerplate. It's kind of like a stack of boilerplate, the best way I can describe it. It's, you know, kind of like trying to describe what a computer is supposed to do. Like, computers can do a lot of things. It's difficult to actually explain what a computer does. It computes, but it's saying that it computes wouldn't really explain to anyone what the computer actually does. If you met someone who's never seen a computer, trying to explain to them what is the purpose of a computer would be a pain, because like all of the things that we use computers for kind of require computers to exist in the first place. So this is the same reason why it's so annoying to explain what this project is meant to do. It's meant to be a boilerplate for all the connections that I'm gonna add to it. 2 millimeters. Okay. So these right here will be our mounting holes for the eye to see. And then what we need, Linux machine for your face. It's Defta. It's not even for my face at this point. It's growing beyond me. Eventually will be too heavy to carry. Okay, around it we need a larger circle. Although we will need to... they will also have to be for construction. I am becoming that guy who just starts 7 million different for construction objects. Okay. And this, and this, and this. All of these we want to be fixed. Because the truth is, we'll need to copy it into a separate... backpacking supercomputer. Even then, this wouldn't exactly call it accurate because it won't have all that much computational power. It will just have a lot of connections. I am gonna utilize the bad boys on the connections of this bad boy to the fullest extent. I've already run out the SPI. Hi, the poncho. What's the struggle today? I'm upgrading the meower is what I'm doing. How would be the best? Oh, I have an idea. Oh, I have a very slick idea. Oh, there's police outside my window. Sorry for the noise, that just happens. This, and then this. Oh, you're going the wrong way. There we go. Now we want a straight line. Where is he? No, I just live in a cheap neighborhood. Okay, this... Oh, why can't you give me a straight line? Come on, just give me... Obviously I want them to be parallel. But to be fair, if I want them to be parallel, then I want all four of them to be parallel. So let me just do this. How is World War 3? Well, it's not World War 3 yet, don't worry. Don't worry, Ruth. When World War 3 blows up, I'll be first to let you know. I mean, because I live here. Alright, this and then this. Beautiful. Then what we want is we want all of these lines to be parallel. What's really neat actually is that the way I've set it up, because I've set it up at an angle, I really did genuinely get good at designing things. Because I've set it up at an angle, and so, for that reason, I can rotate the entire object. So like, if I fix this corner, not what I meant to click on, if I fix this corner right here, yeah, okay, the sizes don't really... Okay, forgot about that, don't mind that, that's fine. Let's do 0.75, because once again I prefer reasonable measurements. Or maybe a 1. If we're going reasonable, might as well go reasonable. Although that might make the edges too big. Yeah, that's true. Which one of us can join your bunker if so? My bunker? Oh no. Poncho, I'll be streaming out in the open. Yeah, okay, this edge isn't really connected correctly. What happened to my mouse? No, don't do that, okay. Beautiful. So right here, this and this tangent. Would that work? Let's go to Switzerland. I don't have that kind of money. You think I'm Mr. Money? Ridiculous. Now this and this. Tangent, this and this. Tangent, and this should be quite nice, I think. Let's see. Oh, I mean, look, I'm professional. Don't mind this line at the bottom. I forgot to tangent it. I really did get good at designing, it's incredible. Now, this entire thing, we need to Control X, and we need to make a new part. Because this will be our I2C connector. If Warlord 3 happens, you know what? What are we doing? I blame all of you. Why did you all have to start this? You know what? No, this is supposed to be a silly live stream where I add an I2C hub to a machine that all it does so far is display a colon 3, okay? Give me something. Come on, I2C hub connected. That's what we're here to do. World War 3 conversation. Come on, people. We're not here to talk about that. We're here to have a silly good time. Okay, now what we need is... we do need all of these to be still fixed. Oh, why they're not fixed? They have to be fixed. I squared T. I only recently realized that it's supposed to be I squared C, by the way, as well, apparently. I genuinely thought it was a quirk of I2S. That's the I2S. I'm still gonna... I squared S is such a... I squared S is such a mouthful. I recently realized, like... I2C. Yeah. I2... it's meant to be I squared... which is dumb! I2C, not I squared C. Whose idea was it? There are... I get the idea of like I multiplied by I, how funny. But there's also two I's. Actually, I2C is so much better. IIC is the acronym. I2C is so much easier to say though. I like I, or maybe it's just me being used to it, that also could be it. Okay. So far, now what do we need here? Well, what we need here is... that's a good question. We need to somehow connect this hub to, I think, these 2 points. I think we'll leave the top left alone. And I think we'll just do these two. I don't even know what this stands for. I don't know either. I know SPI, Serial Peripheral Interface. I know that. But like... what does I2S stand for, actually? Because I2C then is Inter-Integrated Circuit. Which by the Inter-Integrated Circuit is funny name as well. I2S. Inter-Integrated Circuits. Circuits. Circuit sound, I'm fine. I will not go on a rant about how that's not even the acronym. I am okay. I am calm. I'm relaxed. I can handle this. I do CS. I squared CS. Even better. I guess I suppose I do have to say inter-integrated circuit is a pretty good description of I2C though. That is name-wise, acronym-wise awful, but name-wise it's really good. Oh wait, I make coffee. I just remembered the song I'm listening to has coffee in its lyrics, and that just reminded me I made coffee. I did also break my coffee making thing. Hold on. I did. Well, it was so lovely. I loved using the thing, and I broke it. Now you may be wondering, make it, how is it broken? It looks completely fine to me. And yes, so far you'd be correct. This part is fine. I like making my coffee in bulk. because that makes it easy to drink it. Because you don't have to ration it, you just drink it and you pour yourself more once it's done. Because that's not the part I broke. Let's play a game of guess which part make it broke. Hold on, just can't see it properly. I still have the glass in my sink. I haven't cleaned up the glass because it's in my second sink. I have two sinks. One of them is for food and kitchen related stuff. The other one is for chemical related stuff. And this just fell, luckily enough, it fell into my chemical sink. So, which, now that I say it, it doesn't sound like something I should even try. That sounds like a great way to either get superpowers or die. Because all the glass is in my chemical sink. And so yeah. Have you ever tried roasting your own? I know that it's not for me. It's not for me, Root, unfortunately. I feel like roasting... The thing is, I drink coffee in a very utilitarian way. I'm not trying to shame people who drink it as like a hobby. Or like take great care in making. Because I get it. I get it. It's better tasting, it's just better in general. And I understand that. But it's just not my sort of thing. Because I drink coffee for a purely utilitarian purpose. And that is the high, the caffeine high. Alright, let's just make like a simple shape. And then let's clean it up. So this is what we want, effectively. And then right here, features, extrude boss base. 2mm is usually what I go for. Normally you don't need anything more than that. Now let's edit the sketch. And let's think. We could actually delete these now I think about it. Alright. Then I could go with the same approach. Like right here. The problem is that we will need to replace this corner once we get the more components in there, because it's so far very low density, unfortunately. It will need to be high density, because otherwise it's either high density or we need to expand. And expansion is obviously less preferable, because expansion is the simple, easy, good in the short term, terrible in the long term solution. So we obviously want to avoid it like fire. That's lovely, they're all like perfectly defined because they're based on a fixed point. Then we can tangent ourselves to this. We can tangent ourselves to this. Beautiful. Is it applying tangent? I just find it very convenient that it's on the... It is. Alright, good. Then we can make an arc, I suppose. I'm just worried that it's stuck to the wrong point. No, never mind. Good. There we go. And then we just connect these together. And also we want this and this to be tangent, and this to be tangent. Beautiful. I would say that's good. Well, I mean, okay, it doesn't look too great. Hold on. We can unfix this point. Oh, it's not fixed. Well, that's brilliant. We can just move it on. And we can delete this line, delete this line. And we can just... Let's see if it will work or if it will break everything, because either one is possible. Can I tangent? Oh, beautiful. Can I tangent the other way, or will this break everything as well? Because it might. The thing is, this line is very... Yeah, it did. Okay. The reason why it breaks everything is because this line is set to go from this point. We don't want it to go from this point though. Okay, this works. We don't want it to be tangent to that though. We want it to be tangent to this. No, it's still merged with the wrong point. Ah, why you merge with that point? That's not the point I want you to connect to. Or can I just leave it like that? Is this fine? Is this fine? Will this be fine? Let's see for now. Let's bring it over to the big boy, and then let's see. I just made myself coffee and I haven't even poured the cup. What am I doing? I'm too distracted. I'm focusing on too many things. Oh, the battery charger is also there. Do we? I don't think we want it there. At this point, I'm not certain. Okay. There we go. So this is kind of how we want the hub to look like. The reason why we want it on this side is because right here is where we have the pins, and right here is where we have the first component that will use I2C. Is that the same height? Oh, that's actually quite convenient. Accidental design, sure, but I mean, it's not wrong. I do like it so far. The thing that's annoying is that we will need to solder the pins, solder the I2C pins, in order to test this, which will be annoying. Or it might not be quite as much annoying. You know what? It might not be quite as annoying as I think. Yes. Alright, this seems to be fine, I think so. I think this is fine. Later on when we add some components right here, we add some components right here. Well, right here we might not have space, but right here, then we'll need to probably redesign this a bit to accommodate. But for now, it is A-okay and good, and we will be able to disassemble it because it doesn't take in actually any soldering! Wow! Proper planning! It's almost as if if you actually spend enough time working on some stuff, then you actually develop skills. Okay. Let's print. I think I saw a couple of days and I printed anything. I sure hope there won't be any unforeseen consequences to my actions. We'll also need to solder, which will be annoying. Okay. Not now. Daddy's busy. How much? 10 minutes. Not bad. That's pretty good even, I would say. Okay. So, what do we need? Well, we need to disconnect all of these wires. We need to destroy all the progress we've made. I do have a second one, don't I? Do I not have a second one lying around somewhere? I could have sworn. It's actually I'm even more confident than I could have sworn. I'm certain I do. The question is it bent? Because I was pretty certain it was bent, but we did have some troubles with the wiring. So it could be just that. I have so many modules right now. I mean, it's good. I feel like a child at a candy store, but you know. You should do a Clash Royale stream. I don't know about that one. Okay. When it comes to the cables, this one. We only have one of them. I could make more, but pre-made are always better because, well, I'm not that good at making them. So we cut this one in half. One half we want to solder to the RC522. The other half, we want to solder to these pins, 4 of them, which we then want to connect into the Raspberry Pi. That's the plan. Where do we want to connect them? I am so glad no one asked. We want to connect them to I2C. These two, the topmost two, and then also, oh, what kind of power does I2C take? Does it take 5 volts or does it take 3.3? I would guess it's 3.3. Typical voltages are 5 volts and 3.3. The voltage, okay. I feel like I should do 3.3. Just in case. Oh, actually, the screen is using a 3v3. I could do 5. To 3v3. Okay. Okay, not bad. Not bad at all, because you see, our other 3v3 connection is a pin 17, right above the I2s. Did I connect? No! Hold on. I am mental! I am absolutely mental is what I am. I connected the entire... Oh, this is so difficult to explain. But I've connected the entire I2 SPI right here in the middle, right where there is a 3v3 pin, and instead of going for that 3v3 pin, I went for the one on the opposite side. I'm sorry, am I mental? Yeah, that's the voltage pin. What is wrong with me? Above Mosi Miso. Let me guess, green one is Mosi. Then, yeah, it's Mosi. I am just mental. Bye, Jerry, bye. See ya. You should stream the hardest quiz. What is the hardest quiz? I am just mental. Why did I put it in there? I mean, I'm gonna have to test if it works. Because if I mess up the wiring, then, well, that would be quite silly to mess up wiring after everything's been completed. But hey, that's easy to test, isn't it? I can just power it and see. Ha, get it, C, like the language, because I'm running Fix It on C. Well, we'll need to power it anyway. Yeah, no, that looks fine. The screen is, in fact, lighting up. I am just mental. This is ridiculous. I cannot justify that decision. Because now, at the top, we have 4 pins. Oh, the ground as well! No, the ground. I cannot excuse the ground as well. That was the VC, which means the ground has to go down and right of the voltage. So right here. What is 3 pins above the ground? GPIO 18? Oh no! Why are you connected to pin 18? So power and hold on, because this is also wild. We have power empty and this is connected. Pin 27, which is brown, and brown pin is connected to second lowest, which is a restart, okay. And then we go up and right to PCMCLK, a very important pin that we will need later. It is very important, and that is connected to gray, which is BL. If that is black light enable disable, I will be very upset, because that is a very important pin and just a very wasteful usage of it. Is it wave share? It is wave share. Very good. Has to be pin out around here somewhere, right? In this tutorial they say to connect pin 18. I'm sorry, are you mental? You know what, let's just see if it works without that pin. I feel like that's a good idea. Because if it does, if I can just connect the black light to either constant voltage or lack of voltage, and that's what I'm doing. This isn't even a this isn't even a choice, obviously. Hold on, I need to connect my Pi. Yeah, super secret password. Okay. So basically, this will be fun. I'll just prop you up so that you can all see, and then you won't remember how to run fix it. CD surgery, and then CD display taxi test, sudo test. It works! Well, I will be damned. Okay, so that works. Now the question is, if I take the blacklight pin, I'm assuming it's the blacklight pin, if I just disconnected it, now if I run it, well, I'll fucking be, it works! Okay, so how about we don't use one of our most valuable pins on just something that's not necessary? That feels like a good idea. Jeez, that would have been a disaster in the future. Thank goodness I've noticed that. Okay, whew. Right, let me just get back to the pinout. So, in that case, we'd like to use these 4 pins for I2C, I think. Because they're close together, it feels like the reasonable choice. In the meantime, also, the thing printed, because, well, it's a very simple component, and I already almost broke it. Oh, I just realized I haven't, damn it, I've left this filled in, which is, it's a bit yucky, you know. Also, another thing, I've made the hole too small. I don't think a screw will fit through that. Yup, it should be 2mm. Well, simple fix. Simple fix. All we need to do is go right in here, then change this. Oh, not 2, so it should be 3. Why does everything break? Oh, because I'm changing. That is the most idiotic. This should be a 1. There we go, much better. And now this should be a 3. Yes. A bit better. Then what we need is we're gonna do it, nothing works and we don't know why. We do know why, it's because I got the wrong measurement. It's always why nothing works. Always the reason. Okay, so now this we want parallel to this line. Nope. This we want parallel to this. Beautiful. This we want parallel to this. This we want parallel to this. Beautiful. This we want parallel to this. Beautiful. Then the distances between this and the distances between this, I imagine, would like to be the same. And also possibly right here. There we go. And then maybe be a bit lower, and then I don't know why I didn't snap to that, which kind of gets me a bit worried. Yup, and I should always be worried. Okay, brilliant. Thank goodness I was worried, in fact. And there we go. Now if we exit, yeah, much better. And there we have new hub connector. Out with the old one and in with the new. Once again, 10 minutes, so it's gonna be pretty quick. Not great. Certain things I should cook, but I'm not gonna do it on stream. We'll keep going for a little bit. If I get too hungry now, I'll just have to go, unfortunately. Okay. Brilliant, lovely, beautiful, festive. I would like to turn off Fix It, simply because... There we are. Simply because we're about to be soldering, and I don't want to have Fix It in the line of fire. It's a bit risky. I need to find a better place to put it. Okay, you stay right there then. Alright, what we need to do is we need to cut the wire in half. One half will need to go to these pins right here. Black, white, red, yellow. Well, we don't have exactly that, but we do have black, white, grey, purple. we do have an asexual flag of pins, so yeah, we'll go with that. Imagine we may want to have it as close as possible. They are barely holding together, and we might actually need to snap them away. Yeah, truth case, yeah, that's true. Alright, let's think. How far do we need this to go? Really close. Like this. Cutting wires like these always feels wrong. Like, I get that I can, and I do, and I will just strip the jackets, I will just hold them together and we'll be just fine, but it still feels so wrong. And that's why you always leave yourself a little bit of space. Did I mess up again? Not quite as badly. Okay, so it should be fine-ish. Just need to remove the... from the first wire, the ground, beautiful. Then we'll need to do the same with the voltage, the data, and the clock. Clock is yellow, data is white. Oh, I don't like that combination. That's not for me. I use always green for clock. And yellow for signal. It just makes sense in my head. And I can't have it any other way. Call it autism, call it whatever you want. These are the colors that they should be. God dang it. Okay. We have 2. I'm gonna hand them away. We have only 2 left. Can I do 2 at once? Oh, that might cost me dearly. Yeah. Bad idea. There we go. White's also done. Oh, come on. Ah, oh, you are joking. I swear, Red, if you're the last one, I will be very upset with you. What's even worse that these, because the hub, we do genuinely need these to be done properly, and we can't just screw around. Having said that, I think I already screwed up because the yellow one seems to have lost quite a fair bit of course. Damn it! Okay. Could always be worse, remember that. It could always be worse, in fact. How do we connect? That's how we connect. Beautiful. So right here we have 4 separate ones. And also another thing we would like is this, which I haven't used yet. The little buggers that shrink when you apply heat. They're a bit big, but I don't have anything smaller, so this will need to do. I might have cut them a bit short. Well, maybe no, maybe actually it could be perfect. Yeah, fingers crossed, honestly. Because if it isn't, that's gonna be annoying. Oh, it is so much easier to work on with proper tools, I do have to say. I am so glad I bought this. Because otherwise we need to use the Old Faithful, which, well, whilst old, I wouldn't exactly call it faithful. Oh, come on. There we go. First one done. Now it's time for the second one. Beautiful. This is prime entertainment, isn't it? This is content. Watching a man just cut wires. Oh well, inventing isn't all sunshine and rainbows. Sometimes it involves just cutting wires to connect an I2C hub. Okay, 3. Splendid. Pink views. Prime Factorio background. I imagine with Factorio music, this live stream would go really well. Come on, get off. There you are. Okay. Beautiful. We have all 4 of them. Now comes the hard part, because now what we need to do is we need to solder them together. And my soldering setup is, well, let's just say suboptimal, because I'm soldering on the same table as I'm doing everything else. Not much space left. Not much space. I still haven't lost this sponge, which is incredible, no matter how hard I try to lose it. I still haven't lost it. It is genuinely impressive. Okay, now what we'll need to do is we'll need to solder each one of them separately and carefully. Because one wrong move and we'll need to start over because there will be connection between them. Which means we would like to actually bend them out a bit. Careful with this cut. Up. Beautiful. Okay, there we go. They're more spread out now. And so then, have to do it one by one. All right. Let me just get some solder. Because that would be very convenient if they could. They can. That's beautiful. Solder away. First one done. Okay. Now the question is, how are we going to shrink it on there? Because despite what you may think, I don't actually have any... Well, I do have a heat gun, but the heat gun might be an overkill. I'm gonna try my lighter. Yeah, lighter is setting it on fire. Who would have thought that lighter is just lighting it on fire? We're making all sorts of discoveries today. Yeah, no, it seemed to have worked actually. Surprisingly well. Okay. Okay then. First one done. Now on to the rest. Hold on. Second. I'm hungry. It's weird because I've eaten a sandwich. Whoa, that's a lot of toxic smoke. Ah, enough. Don't do that. Too much. Not needed. Okay, 2. That's good. It's time for the third one. Oh, you cheeky little bugger. Come on. Beautiful. Absolutely beautiful so far. Now all there's left is to slide all of these on. Just make sure they don't connect. I've cut them too small. Whoops. Okay, you can fall over. Oh, you can stand up. Hey. Good with me either way. There we are. That's all 4. And then all that's left is to just... I said that's all 4. There we go. And then all that's left is to just shrink them. Yeah, that looks pretty good. All things considered, that is pretty good. But you do need to consider all of them. We just need the soldering iron on the other side and then bring back our good old pal, fix it. And then take out our brand new I2C hub connector. Come on. There we go. Now let's hope that these holes are big enough for M2s. I got the measurements right. Love it when people who design this whole thing actually do use convenient numbers for measurements. Makes everything so much easier. Okay. We can use something small like this. Yep, beautiful. 2, 3. And then all we need to do is just screw all of these on. And then where are we supposed to go? Right here. Oh! Did I screw it on upside down? And also, One of the connectors I've used... No, I didn't screw it on upside down. I just... Oh, you are pissing me. One of the connectors I've used was actually for the Raspberry Pi 5. Which means we would need to connect this to both the Raspberry Pi 5 and... Ah, that's quite annoying. Yes, it will need to redesign. But the point is, this will go right here. There we go. Like so. Actually, I guess I could just screw it on right here. Yeah, right here was also the correct rotation. That is so unbelievably annoying. Oh well. I suppose I could bring up the Raspberry. Because I do like the idea of dual using all the connectors for all the things as well. So I could bring up the Raspberry. And then on each corner we could do the same kind of thing. That would be more convenient. Yeah, that's probably what I'll do. But that will be it for this session because I'm genuinely really hungry. And so I'm gonna go. I'm gonna eat something. And then I'm just gonna work on the videos. Like the physics video, which should come out this Friday, hopefully. And so for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye.